emergency pens. This is a worksheet that actually comes directly from a college board, which is kind of ironic that the answers are completely wrong on the college board answer key. It's pretty funny. But so as our book talks about, we do the very lowest level of differential equations, which are separable differential equations. It's the baseline, sort of very beginning of differential equations. And so what we want to be able to do is to recognize when we actually can. And this does happen a lot in the AP test. They'll ask a question, how would you separate these variables? So like, what's the next step in solving the equation? So you don't actually have to solve it. You just have to figure out that first step, which is the hardest thing. So I just want to look here, number 6. This one's the easy one. We basically have a proportion here. And if we wanted, all we had to do is multiply the 2y to the left-hand side and then multiply the dx to the right-hand side. And so because there's an easy thing to do there, that one is absolutely separable. We can get all the y's on one side and everything with an x on the other. And that, of course, then would match number F right here. Oh, number F, letter F. All right, so I just want to go down the line. And again, most of this is, once you see it, you're like, oh, right, we can do that. It's a lot of just remembering some old techniques here. And B, choice B, not separable, can be used more than once here. What do we think about number 1? Do you think it's possible to separate? Yeah, this is not separable. And so what's interesting is, like, we have to be able to do it with multiplication and division. So, for instance, I can't add 2y to both sides. We're not allowed to add things to the other side, because then we would have this, like, 2y plus dx or dy, which is not a thing, okay? It has to be a product. So that's no good. That is not separable. What about e to the y minus x? This is a real tricky one. But we sort of talked about it yesterday. We have some exponent rules. So if you had like e to the u times e to the v, if they have the same base, then you're allowed to add the exponents, right? Well, that goes both directions. And it's also, if we had e to the u over e to the v, if they have the same base, what do you do to the exponents? Subtract them. So that would be e to the u minus v. So again, these are exponent properties that are useful. So when we see this subtraction of exponents, then I can go and back up to the division step. And so this really is e to the y over e to the x. Now, can we separate that? Yes, we can. So we could absolutely divide by the e to the y, or really it's just e to the negative y dy. And then this is, we'd have 1 over e to the x, and I can multiply the dx to the right-hand side. So we absolutely could do that. And of course, 1 over e to the x, we could also rewrite as e to the negative x. So as a reminder, so that is letter D. Oh, oops, I meant to cross off S. All right. What about 3? Can we separate those? I can't take a 3 out of the first term. So yeah, like I'm looking for, they have an x in common. If I take out an x, I have x plus 12y. So again, if you can factor, then maybe we can do it. But this still has x's and y in here, so this is not separable. So what about this one, though, number 4? Do we have something we can take out of that? Now this one again, we have an x. So we could undistribute that, and that would leave behind what? Come on, boys. If you take an x out, what's left behind if you undistribute? Oh, thank you. Y plus 12. Very good. Okay. And again, so now this is a product. So yes, we can separate this. We can divide by the y plus 12 right there. So we divide that y plus 12 to the other side. And so that's A. What about number 5? What can we do with that? Again, we can't add things, but if we can factor something out. So I see a negative 2, maybe I could take out of both of those. So I take out a negative 2, what's left behind? Y minus 6. And then, now that that's a product, I can divide that y minus 6 to the other side. So we get 1 over y minus 6. And that negative 2 stays on right. Okay, so there we go. So that's C. Number 7, we got adding of exponents. So how would we rewrite that? Times e to the y. So now again we have a product, so then we can divide by e to the y. And if we divide by e to the y, that works. Becomes e to the negative y, and e to the x is going to stay where it's at because it's just fine. And we multiply the dx over. So that's G. Here again, I can't just add 12y to the other side. We can't add and subtract things. We have to do multiplication or division here. So, and this one is not factorable, so this is not a separable equation. And then number 9, straight up proportion here. I can very easily take my denominator and multiply it to the left, take dx, multiply it to the right, and that gives me right here letter E. Okay? So again, that like first step in solving differential equations is really the big step. And then I want to go through these first things here. These basically outline some good steps for solving differential equations, and we want to basically analyze what the mistakes are. So again, I don't want to spend too much time with this. I gave you a Delta Math assignment tonight, and we'll do some Delta Math problems because they're a little bit harder. Gave you the level 2 kind to try and practice with. So let's see here. We have a major mistake and some line of the work here. And so here's my original equation. And if I were this student, I would want to move my y squared to the left-hand side. So I would want to divide by y squared, and I need to multiply my dx to the other side. So let's see. So they divided by y squared. That's y to the negative 2. That counts. It looks like they also moved the negative over to the left. That seems fine. Okay, I can do that too. And so on the right-hand side, I'm left with my x over 2 times my dx. All right, that seems totally legit. Could get that. So then now do we take an antiderivative of the left here? So I would get y to the negative 1 divided by negative 1. So my negative cancels out. So I've got my what? That's good. And here, I'm going to increase my x by 1 and divide by the new power. So I get x squared over 2 times 2, so that's over 4. So that seems good. And they even have the plus c1. A constant there. Okay. So, what happened between step 2 and step 3? It flips. Yeah. Which is a little bit weird. So this is the issue, actually, this very last thing that they do. So we're going to jump from here. And you may not know this, it's kind of a weird thing, but we have y to the negative 1. If we have a fraction plus a constant, you can certainly take a reciprocal of both sides. Just like you can square both sides of an equation, you can take it to a power of negative 1. That's going to flip both sides. But in order to do that, you must have a proportion. So if you have a over b equal to c over d, and you want to raise both sides to a -1. That's going to flip the fractions. You're allowed to do that. But they have to be in a single unit fraction. So all together now. So what we want to do here is get a common denominator. So here we have, I'm going to just put it over 1, and I would need to times by 4 if I wanted to get a new number there, to get a common denominator, so I can write x squared plus c sub 2 all over 4. So basically, you need to get that common denominator first. Now, we can take everything to that -1 power. A power raised to a power, we multiply those together. That's going to flip our fraction, essentially. Becomes +1. And again, this one's going to flip upside down as well. So we get 4 over x squared plus c sub 2, or we don't really need the subscript. It's fine with just the c. That is the mathematically correct way to do it. This does not come up very often, okay? It's a little bit weird, but before you can flip fractions, they need to be a single unit, all together fraction. Okay, let's look at number 2. All right, again here, this is really e to the x divided by e to the y, reversing those exponent rules. So if I were a student, I would take the e to the y and multiply it to the left-hand side. Oh, and multiply the dx to the right-hand side. Wait a minute. They have e to the -y. Is that right? No. So that's the wrong step right there. First step is wrong, which is why I rewrite things where they make a little more sense. So all I had to do was multiply the e to the y and get dy. And then on the right-hand side, we have e to the x, dx. And then from there, we can integrate. What is the integral of e to the y? E to the y, very easy. And the integral of e to the x is e to the x plus c. All right, now here's some fun stuff. I need to get y by itself. What's going to allow me to take my power and drop it down? We did a little of this yesterday. Natural log, yeah, we need to take a natural log of both sides. Notice the parentheses I'm using, pretty important. So that gives me y times the natural log of e equals the natural log of e to the x plus c. Natural log of e is 1, so we get to lose that. And so we get y equals natural log of e to the x plus c, all in parentheses. And that is perfectly correct. So this is just really good practice for, you know, how do we integrate some things again, and really just some exponent and log properties. All right, let's see. Looking at problem 3 here, I see the y. I would like to divide to the other side, and I like the dx to move to the right-hand side, so I can multiply that to the other side. And that looks just about what we've got here. So 1 over y dy. I do like writing things as 1 over if I can, because 1 over something is a log, natural log function. All right. And then we got x over 2 dx, so that looks good. That's the right step there. Antiderivative of 1 over y is the natural log absolute value of y. Increase your power, divide by the new power. Oh, what's missing? Plus c, there it is. Natural log absolute value of y over x squared, or sorry, equals x squared over 4 plus c is the missing part there. All right. Now, again, if I'm trying to get the y by itself, I need to get rid of the log. How do you drop a log, ladies and gentlemen? Oh, I said it all day yesterday. Swirly! Gotta do the swirly, that's right. All right, because remember, this is really log base e, And so what we're going to do is we're going to take that base and we're going to swirl around, and this whole thing gets lifted up as a power. All right? And so then we've got the absolute value of y equals e to the x squared over 4 plus c. And remember, once again here, x squared over 4 plus c, what allows us to add the exponents? Yeah, multiplying. This is e to the x squared over 4 times e to the c. What is e to the c, though? E to any number is just another number, right? So it's just a constant. And so just a constant. I'm going to write that down for you. Just another constant. All right, and so we can sort of relocate that to the front of the line here. Absolute value of y equals ce to the x squared over 4. And then to get rid of the absolute value can always be a positive or negative based on what we need. So it becomes y equals plus or minus ce to the x squared over 4, which again, you don't really... I like to include it because I think it's important. We need to pick one, but it will take care of itself when you're solving. It'll be negative if C will become negative if it needs to become negative as you're solving. So really the CE to the x squared over 4 is good. You're going to get practice on this one today in Delta Math. They get really complicated too, so go slow. And then last problem number 4 here. When I look at the original, I'm thinking I want to multiply the y to the left and multiply the dx to the right. All right, that first step looks perfect. Antiderivative, I should get y squared over 2. And then here we should get x squared over 2, which would cancel the 2. So we just have negative x squared plus a constant. And then what would you do from here? Try to get y by itself. So my first step would be to multiply. Yeah, so I'm going to multiply both sides by 2, really, and I'm showing that. So these cross out, and then this becomes distribute the 2. So negative 2x squared plus 2 times your constant, which is just a different constant. And then we need to take a square root. Oh, what's missing on the square root? The plus or minus. Yep. Why did I have a problem with the... That's totally weird. I don't know what I did there. Really, this is the big thing here. Y equals plus or minus the square root of negative 2x squared plus c. And again, you can only pick one. You can't have both, okay? And again, picking one depends on whether your initial value is, if that y value is negative, you're going to choose the negative, is essentially what it comes down to. Okay. Questions? Is there a mistake that you're seeing? For some reason, I thought it was step 2, but I don't know why I would think that. No, I think it's right. Okay, cool. Oh, there is one more. There's one more in the back. Look at that. I didn't realize there was one more on the back. That's so funny. There's something very wrong with this. It's just not like the V what? We can't integrate V in terms of Y. That is no bueno. I didn't realize that this was on here. I'll look and see what it says, but I don't think that we can do that. But there again, another mistake on the College Board worksheet. It probably is a mistake. We're going to do some Delta Math together here. And if you need, you can always look through the example or watch a video for a little bit more clarification. But we're going to try